So chapter 17 is about equilibrium, and I promise you, if you work to understand this chapter well, then chapters 18 and 19 are going to be so much easier when we return from spring break, because really they are just applications of equilibrium. So 5 skills again for equilibrium. The first skill that we're going to talk about is what is equilibrium, what's an equilibrium constant, and how does that play into what kind of chemistry happens. So for this whole process, I want you to envision equilibrium kind of like a teeter-totter, right? But it's some important things to think about in terms of equilibrium is it doesn't necessarily mean equal. So that doesn't mean that this is where our teeter-totter wants to be. For some reactions, it might be here. For some reactions, it might be here. And again, this just has to do with how many reactants versus how many products that we have. And so where our teeter-totter wants to sit is our equilibrium, and we define that as K. And we'll work to figure out how you actually calculate K and how you represent it with an expression for equilibrium. But this might not be where your teeter-totter is. So we call that a reaction quotient, or Q. So a lot of what this chapter is about is where are you at, which is your Q, and maybe it's here, and where do you want to be? That's your K, and that's here. So we first kind of have to define these, and then we spend a little bit of time talking about the difference between solution chemistry, which will have concentrations with molarity, and gas chemistry, which has concentrations in terms of partial pressure, and how to kind of relate and think about these. So that's the first skill, is thinking about equilibrium, equilibrium constants, and then what we call reaction quotients. So thinking about where are you at and where do you want to be. Kind of second skill moving off of that is saying, well, to figure out where you're going to go, you have to compare where you're at and where you want to be. So that's kind of what we call a Q versus K comparison. So we'll work on that. And again, molecular scenes problems are going to be an important piece of that problem, or that kind of skill. The bulk of this chapter really is our third skill, which is solving equilibrium problems. They come in generally 2 flavors. One is you're given all of the equilibrium concentration information and you have to calculate an equilibrium constant. Those are few and far between. More often than not, and the more kind of applicable use of equilibrium problems is saying, here's an equilibrium constant for a reaction, and here's what your starting concentrations are. Now go and tell me if this is where your teeter-totter started out at and this is where it wants to go. How are we going to change things? How will concentrations change? And again, understanding this skill, learning how to do something that we call ice tables, which are ways that we can quantify and keep track of the changes that happen, is a really, really critical skill for this chapter. And again, this is the kind of things that we'll build on in chapters 18 and 19. So that third skill, equilibrium problems, is where we'll spend most of our time. Now the fourth and fifth skills kind of build off of this as well. The fourth skill deals with what we call the Chatelier's principle. And this has to do with predicting the direction that will shift equilibria by perturbing a system or doing something that changes it. So for a reaction, what happens if we are at equilibrium, our teeter-totter is where it wants to be, and we throw in some more reactant? How will this shift? What if we throw in some more product? What if we remove some product? So Le Chatelier's principle is kind of qualitatively thinking about what happens as we change a system and how will it shift. So we can think about that qualitatively in terms of predicting a direction, but we can actually use some of the previous skills to quantitatively determine how it's going to change. The last skill, as we have kind of defined by your kind of chapter summary sheet, is really just thinking of a practical application to tie this all together, and it has to do with nitrogen fixation or ammonia synthesis. So kind of a neat big picture kind of application that we'll use to kind of pull that all together. But again, I promise you, if you learn equilibrium well in this chapter, it will pay off in huge dividends, because the next 2 chapters, chapters 18 and 19, which is what exam 3 will be, is all about applied equilibrium.